record it again. Okay. Now, okay, thank you for the feedback. Okay. So we need to start the frequency modulation. Frequency modulation. Okay. So we will continue and I will give you a break. Okay. Anyway, so I think 15 minutes enough to explain. Okay. This part. Okay. Then I will give you a break and also example to do. Okay. Uh, okay. So we will start frequency modulation. Okay. So, yeah. Okay. So, actually this, so normally, okay. So one thing is that, okay, this FM and PM, okay. Before that, okay, so I have explained that AM, amplitude modulation, these DSB, SSB, those are linear CW modulation, continuous wave modulation techniques. Okay, these are linear modulation techniques. Okay, linear means if you consider a message signal, okay, message signal, and in the modulated signal also, XMT, this is the modulated signal. Okay, this modulated signal is directly related with the message signal. Okay, or spectrum of the message signal. Okay, so linear means, okay, modulated spectrum, directly related with the modulated spectrum, directly related with the information spectrum or message spectrum. Okay, message spectrum. Okay, so you can see them, no? You can see them. Okay, so this is the spectrum for amplitude modulation. Okay, and you can see that spectrum here you have omega c minus omega m, omega c plus omega m. Okay, so here the spectrum is directly related with the omega m. Here no omega m parts. Okay, so there is a direct translate actually. Okay, modulated spectrum is a translated message spectrum. We can define like that. Okay, we can explain like that. Okay, but this FM and PM are not linear CW modulation techniques. Okay, in other words, okay, these are not linear. Okay, and so you can see that also the waveform is also not linear. Okay, it is a function of a function. Okay, I have explained it in the phase modulation. You can check. Please go through that lecture, then you can understand these things very well. Okay. So I have explained this one also in the PM lectures. Okay. So you can get a good understanding on this. Okay. So just I tell you the summary here. Okay. Okay. So in nonlinear, okay, the modulated spectrum is not directly related with the message spectrum. Okay, message spectrum. We can't simplify the spectrum actually. Okay, here we can, in linear modulation we can simplify the spectrum, but in nonlinear system to find the spectrum is more complex. Okay. Okay, so that is one property of nonlinear. Okay, And another property is there, that is we call transmission bandwidth. Okay, transmission bandwidth is very much greater than twice the message bandwidth. Okay, and I think you know what is bandwidth. Okay, so you have message bandwidth and modulate transmission bandwidth means modulated signal bandwidth. Okay, so the modulated signal bandwidth is normally higher. Okay, and in the nonlinear modulation, it should be very much greater than the twice of the modulated message band. Okay, in linear, normally in linear also message bandwidth is greater than bandwidth is normally less than the transmission bandwidth. Okay, so that is the normal in non-linear also, but in non-linear it is very much greater than the twice of the message bandwidth. Okay, so that is the difference. Okay, and another property is there, that is in nonlinear we can increase the SNR. Okay, in linear. Okay, in linear. Okay, so you can see that. Okay, okay, so if you are using the amplitude modulated signal, your information, so let's say that DSB, you are using a SSB. Okay, you are using SSB. Okay, so your message signal will be AM squared by 2. Okay, so this is your message signal. Okay, this is your message signal. Okay, and the message signal power. Okay, this is the message signal power. Okay, and the SNR you can define as SNR, you are normally defined as signal power divided by noise power. Okay, so to maximize the to increase the SNR, you have to increase the signal power. Okay, so once you are increasing the signal power, what happened? The transmission power also increasing here. Okay, the transmission power also increasing because this is a transmitted power, no? Okay. So, okay, so in nonlinear, so I think you got it. Okay, it is very simple. Okay, you can understand that one. If you have any problem, please ask me. Okay, so in nonlinear, in linear modulation, if you increase the signal power, the transmission power also increase and SNR will be increased. Okay, in other way, if you want to increase the SNR, you have to increase the signal power, then also you have to increase the transmission power. Okay, transmission power increasing means again, maybe your battery maybe drain soon. Okay, so if you want to increase the SNR in linear modulation, you have to increase the signal power, then you have to increase the transmitter. Okay, so it is a disadvantage actually. Okay, but in nonlinear, I will explain. Okay, I will explain it later. But in nonlinear, okay, nonlinear modulation, you can increase the SNR without increasing the transmission power. Okay, without increasing the transmission power, you can increase the SN. Okay, so these are the property of the nonlinear techniques. Okay, and so this is one advantage of nonlinear technique. Okay, the SNR can be improved without increasing the transmission power. Okay, but in linear, if you have to increase the SNR, you have to increase the TX power also. Okay, so anyway, we will have around 20 minutes break and we will come back. Okay, so if you have any problem, please ask me. Okay, related with what we have learned. If you have any problem, please ask me. Okay. So just have around 20 minutes break and we will meet. Okay.